Hello teacher, in this video I'm going to show you the exercise and examples where we ask to do from creating a counter on a display to measuring the temperature and humidity of a room. Starting with the first example, we're going to create a counter on an analog type display which will count from 0 to 99 and restart after finish. We'll start as usual by opening Microchip and creating a new project. This assigning that we'll use the Atmega 328B. After opening, we'll proceed to open MCC. Here, the clock will be changed as usual to external clock on the CPU. This, and then pins 3, 4, and 5 will be assigned as outputs on port B, changing their names to SDI, latch, and CLK respectively. We generate and send the configuration here for the microchip project in the project resource tab at the top left. Before writing the code in microchip, we must first add the necessary libraries from the circuit to function properly and orderly. To do this, go to the right tab here of Solution Explorer, right click on the project's name and add an existing item. Yeah. In the File Explorer, search for our libs74 list, libs74 hc595.h and .c, these two. Okay, now let's start with our code. First, we include the delay code and the add library. We create two arrays containing the numbers generated with the displays and its counter that will start with 0. We generate and call the add library and add the arrays for the data and the numbers location. We write the code for the tens and the assigned delay in position. This we write the code for the tens and the assigned delay in position. And since we're working with a node type display, we'll place this symbol here. This is important. Okay. We do the same now for the unit and go to the while loop. Here we put a for. We put a for loop for the counter, and every time it reach 99, the count will reset to 0. Okay. We finish and generate the code, and we go to Proteus and create the following diagram. Here we use 274 HC595 and the anode display. Okay, we run it and we can see that the counter starts at 0. We wait one moment. Reach 99 and resets again to 0. As you can see, here's the counter that goes from 0 to 99. I'm using a 7 segment common anode display, specifically quad mode, as it will be showing the counter from 0 to 9999 shortly. Let me restart. I will wait until this ends in a moment. And ends. For practice 6, we'll do the same as practice 11, but this time we'll make the counter on display go to 9999 and reset to 0. We'll follow the same steps as in example 11. We'll open microchip at Mega 328P, set the MCC as in example 11, like this, and add the 74HC595.h library. The difference from example 11 is that we'll add two more arrays, the 100, here, the 100, and the millers, and 1000, sorry. To do this, we'll follow the same steps as the previous example, but changing the operation to display the number in the correct position, its position, and the array, assigned array, as you can see here in the 1000. Yeah. The same with the hundreds, and all the way down, we change the if condition. Instead of resetting when it's reached 99, it will reset when it's reached 9999, right? We generate the code and go to the Proteus. In Proteus, there will be no other change other than the display, since using four numbers will require a common anode what display, okay? In addition to adding the other two cables to the display to power all the slots. We let it run and just wait to reach 9999 to see the results. I will wait here. So the counter will restart again. So as you can see, teacher, how far can one go? This is practice number 6. Here you see the counter from 0 to 9999 with the common anode. I'm going to reset it and show that it resets when it reached the last number. It will give a little time, so let me wait 1 minute. The counter ends and start again. For example 12, we'll use the 2x16 LCD to display a dialog box on its two lines with force sentence. We'll do the same as the first exercise. Open a new project in microchip, select the Amiga 328P and open the MCC. But for this example, we only add the external clock, okay? We won't assign any ports and pins or pins. We'll leave it as is and generate it. Now for this circuit, we'll use the LCD library, yes, and its others. To do this, we'll do the same as before, right click, add an existing item, or item existing, and we'll search the download files for the following libraries and add them. After adding them, we'll open the LCD library by double clicking it, paying attention in this section. We'll open, and if we want our test be simulated in Proteus, we'll leave the code as it shows here. We'll leave the code on line 8 commented out, where it says for real testing, and line 9 uh, uncommented, where it says for simulation in Proteus. Yes. When we want to test it on a physical breadboard, we return to the library and comment out line 9 and uncommented line 8. Now we go to the code. First, we add the delay code and the LCD library. We'll write each line that will be displayed and used for the LCD on each line. Then we assign the delay and the LCD and go to the while loop. Here, we program the following in the LCD. In this case, line 1 will tell it to display the first line we assign on that line here. This line we assign on line, this one here. We do the same for line 2 with line 2 and assign the delay finally. We tell it to clear the LCD. We repeat the same for the other two lines and the other two sentences, including the delays and the clean LCD. We generate the code and go to the Proteus. Here we use two resistors and the PCF8547 for the LCD. Otherwise, it won't turn on. We send it to work, and you can see how it displays the game titles. Sorry, that's all for this example. This is example 12. You can see how the LCD displays the aforementioned text and the name of the university. There are some lines in the middle that have been erased, as if those pixels have burned out or aren't light up, but you can still understand what you're seeing, right? For practice 7, we'll do the same demonstration as example 12, except now we'll display our full name and license plate number on the LCD. We'll do exactly the same as example 12, the same microchip on change MCC and the same LCD library. In fact, here's the code from example 12, except now I change the lines to display my name and my plate number license. Okay? The delay and LCD commands remain unchanged. They won't be changed. We will decode and open in Proteus. Since there are no difference, it will be designed the same as example 12. We launch it and there is it, our name and license plate number. Now you'll see the physical code. Here's practice number 7. It's the same as the previous example, but it shows my name and my student registration number. This actually is the same. There's no difference. For example 3, we'll create a circuit that displays the current temperature and humidity using a DHG11 sensor and a 2 X16 LCD display. To do this, we'll open microchip, create a new project, search for the Amiga 32HP, and open its MCC. Okay, in the MCC, in addition to the external counter, we only configure one port and one pin. In this case, we'll use the PD4 and assign it as the input pin. Yes, we generate it and go to the microchip. In microchip, we'll add the same libraries as in example 12 and also add new ones, namely those for the DHT11.C and DHT11.H. That is the sensor. Just like in the previous codes, we search it and add it in the project. Now in the code, we add the LCD.H and DHT11.H libraries. We write the DHT11 library arise and the LCD start. Okay, here. Here we'll add an if that a statement to condition each time the DHT11 is detected. Yes, in this. This way we can find the temperature and humidity and then proceed to the configuration. We'll note that the temperature captured by the sensor should be displayed and send it to the LCD. And the same with the humidity. We'll set the data capture delay and close the curly brace. We'll generate the code and go to produce. And here's the clear diagram. I don't know why I didn't think of recording the exercise this way. It's much more convenient. Here's the example 13 in physical form. You can see how the current temperature and humidity of the room are displayed. If I increase the humidity, the LCD will show how much it's increasing. The same goes for the temperature. If I heat more or cool less, the sensor will display it on the LCD. You can see the humidity is increased, and for the temperature is, since the room in is very hot, I will have to cool it manually until it drops to a temperature of about 30 degrees Celsius. It will take a time. Okay, you can see the temperature is the degrees. For practice sake, we'll vary example 13 and now set some conditions. If the sensor detects a temperature greater than 34 degrees Celsius, it will display a warning that the temperature is high. The same goes for humidity. If it detects humidity greater than 79 degrees Celsius, it will warn that the humidity is high. For this, we'll follow the same steps as in example 13, microchip, MCC, and libraries. The same. Once we finish the code again, after assigning the temperature and humidity, here, Later than this is new. Okay. Um, so we'll open an if a statement in which we'll set the following condition. If the temperature is less than 35 degrees Celsius, we'll add a text indicating the current degree Celsius and the message that the temperature is high. We'll do the same with humidity. If it's less than 80 degrees, it will display normally. Otherwise, it will display the humidity and the message or the warning that there is high humidity. We use the else statement to indicate what happens if the if condition is met. That is, if there's an increase in both data points, this change what's going to be displayed on the LCD. Then we go to the delay and to clean the LCD. We build it and go to the protects. Nothing changed here is exactly the same, and we'll show the simulation in a moment. In example 8, the only difference is that when the humidity is 18 degrees Celsius or higher, a warning will appear indicating that the humidity is high. The same thing will happen with the temperature. If it exceeds 34 degrees Celsius, a warning will appear indicating that the temperature is high. We'll show here the humidity. Okay, you can see it show a warning that the humidity is high, and with the temperature it only will happen the same. Degrees Celsius, the warning appear and indicate that the temperature is high.